give yourself lots of practice on these. No two are created equal. We will have a whole day of practice on Thursday. Which I'll get to in a second. Let's give it a shot. So first of all, what is our model here? You could really swing this one either way based on theory. You could swing this one either way, right? We know our outcome is what? Performance. Good. And then it really could be training or challenge, right? So you could say, well, does the effect of challenge on performance depend on training? That makes sense theoretically. Or does the effect of training on performance depend on level of challenge? It could be challenge in the training, for example. What way would you set it up based on the information that you have here? Training moderated by challenge. Why? Fine. Fine. Why you gotta be logical? Even if it didn't say the word moderator, what's the other, even if it's that, why? Because your axes, right? This is your what axis down here? X, that's your Y, right? We're looking at literally at how the relationship between X and Y changes based on Z, right? Based on that moderator level. So it's set up right now graphically such that training is our X and challenge is our moderator. That's critical to understand your model because the interaction term is flippable, right? So if we write out this equation, y equals 16 point, I'm writing the moderator model here, 16 maybe 0.17 plus 1.54 training plus 2.60 challenge plus 0.76 training times challenge, right? That moderator term could go either way. That's the change in slope between training and performance for a change in challenge, or it's the change in slope between challenge and performance for a change in training. The only way that's going to make you change the way or inform the way you tell the story is how you set up your theoretical model. So your theoretical model here is really important to the storytelling component. So now the question is, first of all, the first question we always ask is, does the relationship between training, should go here, right? Does the relationship between training and performance change based on challenge? Yeah. Yes or no? How do you know? What's the best statistical evidence to tell us? Kayla? The change in R squared between? Good. How do we talk about the different models? So I'm going to expand on what Kayla said, get good at the detail. So the change in R squared between model 1, which is what kind of model? What's in model 1? Main effects only, right? So this line and that line, right? So we have model 1 was a main effects model only. So here was model 1, training, challenge, both to performance, right? And a second model, which added in the interaction, right, between training and challenge, explains significantly more variance in performance than the main effects. Therefore, we have an interaction going on. Good. So the answer is yes. We've got our evidence. Now the question is how, right? So how does training change the relationship, or sorry, how does challenge change the relationship between training and performance? Let's start with where the relationship between training and performance starts, right? When challenge is what? Average. That is right here. So here we have the relationship between training and performance when challenge is average. Why do we know this is when challenge is average? This is super critical. Centered. It's centered data, which means what are we plugging in this moderator term? Right, we're plugging in a 0 for challenge, meaning the moderator term, the change in slope, doesn't impact anything. It stays at 1.54. So here is 1.54. That's the slope between training and performance when challenge is average. Now we can look at the change in slope. When challenge goes up by 1 point, what happens to the relationship between training and performance? Let me say that again. When challenge goes up by 1 point, what happens to the relationship between training and performance?
Increased by 0.76.
Good. It increases by 0.76. That's a change in slope. So starting slope is 1.54. And as challenge goes up, right? I literally have to think about it as a bump. So if this is training, here's its nice little 1.54. It's sitting there, right? In comes challenge and it's change and it hits that 1.54 and changes it by this much, right? So that 0.76 gets added on to 1.54. What happens if challenge goes down by 1 point? Gonna go down by 0.76. Now, 1 point changes aren't very helpful to visualize. So in the graph, we don't have 1 point changes, we have 1 standard deviation changes. So here we have the graph. This is when challenge is what? Low, right? 1 standard deviation below. Here's when challenge is high. Now, the question is, what are these slopes? We can look at it and we can see it looks when challenge is low, right? The relationship between training and performance is actually negative. So when you're in a training and it's really dull and not hard, then actually training has a negative impact on performance, right? When you're in a challenging training, right? Then the more training you get, the better you get at your job. As long as that training is what? Challenging. The question though is, do we know whether these slopes are significant or not? From the graph, no. From the simple slopes, we do. And what do we see? At high challenge and low challenge, they are, right? At average challenge, there's no relationship. Yes.
How can a simple slope really average and also then affect these?
Question.
Would it just be the same? Would it just be the same thing?
They should be the same. So first of all, they should be the same.
Jess, sorry, could you repeat the question for the online cohort?
They should always be the same, exactly the same. JJ was asking how this main effect is significant. This is not. Without looking at what happened, I have no idea. I could be totally honest. You're right. It should not be. Why would that be?
The slope of the interaction, not the slope.
No, this is the slope between training and performance when challenge is average. This should match. This should match the main effect.
In the purpose state.
I don't think so because I ran it. I don't think so.
Happen in standardization.
Could have been. Let's not worry about that because I have no idea of telling you what happened. Good catch, because yes, it should be. We'll look at that very carefully in today's output, which is definitely matches. I checked. All right. These are significant, right? These are significant. This is not. I wouldn't expect this one to be. So I think the simple slopes output is right? So when challenge is average, there's no relationship between training and performance, right? Make sense? So in general, sometimes training and performance works, sometimes it doesn't. It depends on what? How hard it is, right? So when the training is hard, performance goes up with more training. When training is low or when challenge is low, performance goes down with more training, right? Now, here's a very important trap that people fall into. They say, oh, performance goes up when it's harder. What is that? That's a main effect of challenge. This is changing the relationship between training and performance, right? As training goes up, what happens to performance when challenge is high, right? When you are describing a moderator effect, make sure you have both the X and the Y in your storytelling. If you say the moderator and the outcome, you're actually looking at the main effect. That's a pitfall I see a lot. Talking it's a moderation, you're actually talking about a main effect. Cool, we're gonna do more. Today, yes, quick, very quick. We have a lot left.
On the simple slopes, where it talks about the outside the interval, is that the plus or minus 1 sigma?
Today it categorically depends. This was such a fun lecture to prep because it was one of those lectures that made me remember, not that I ever forget, really made me remember that I really love teaching because it was like done. And then I looked at it to get ready and I was like, oh no, wait, there's 5 million things I could do to make it better. And then I did. And so I was super excited. So I'm really excited about this lecture. Reminder really quick, Stauffer on Thursday, right? So we've got our Stauffer on Thursday. I'm stoked about this one. It's a COG speaker. It's a COG speaker that really cuts across all of the different disciplines. And she's talking about how thinking about the future actually changes current behavior. And it's online only. So nobody has an excuse. We can all go. We can have our kids in the back screaming. Cool. So I'm really excited. Thursday at 4 to 5. online only. You should have approximately 3,000 emails in your inbox about it. Cool. All right. So we're going straight into an example because we're pretty good with the what is moderation stuff. Literature suggests that income is a predictor of quality of life. We looked at this last time. Cool. Except you think this might depend on industry. Okay? So our research question in Statsy language would be, does industry moderate the relationship between income and quality of life? What would it be in less Statsy language? What's my favorite non-Statsy moderation word? So what would it be?
Does the relationship between income and quality of life depend on the type of industry?
Good. Does the relationship with income and quality of life depend on industry? All right. So remember, a reminder when we fit moderation models, this is our theoretical model, right? We've got a relationship between income and quality of life that exists as if we're not considering industry. We actually think that that line, that slope is going to change depending on what industry people work in. That's why that industry is coming in and hitting that slope. It's literally hitting it and changing its magnitude, right? It's beta. Statistically, though, we can't regress things onto lines. So we are going to run it this. We've got income, main effective industry, and then the interaction. And we always run the main effect of the moderator. It's maybe not in our theoretical model. It could be. It might not be. We always run it in our stats model because we want to know if our interaction explains additional variance above and beyond the main effects of our two predictors. Good so far? All right, we know our general structure of our model. It's no different with a categorical variable versus a continuous variable. What's the only difference? What are we gonna have to do? Dummy code, right? It's gonna end up impacting our interpretation a little bit, right? This is, I think, where it gets a little bit complicated, the right word. To be careful, right? There are a lot of pieces. There's a better word. I'll think of it. Here's our raw data. We've got our employee number on the left. We've got income, we've got quality of life scores, and then we have industry. So we've got 3 industries: technology, agriculture, and government. What's the first thing we have to do if we're going to run a moderation to our data? Center our data. What predictors are we centering here? Income, right? First of all, we're going to center income. First of all, we can't center industry yet because we don't have numbers. There's nothing to center. So first thing I'm going to do is I'm going to center my income. Another review of centering, because understanding centering is super key. Let's zoom in on someone. This person's centered income is 4.32. What does that mean? What do they make?
4.32 above the average, whatever that is.
4.32 above the average, whatever that is. Good. What does this person make? 6.6 below the average, whatever that is. If someone had a perfect 0 in here, what does that mean they make? The average. That becomes critical because when we plug in zeros, what are we really plugging in for income? Average income. That's starting to make more sense now. I can see it getting quicker. Good. Don't freeze on me. There we go. All right, next thing I'm going to do is I have to dummy code. We've got 3 levels of our categorical variable. So we need how many dummy codes? 2. Here they are, right? I'm going to call them J1, job 1, and job 2. First one is the shift from agriculture to technology. Second one is the shift from agriculture to government. So what's my reference group? Ag. Good, right? So remember, these 2 together, 2 variables, 1 construct. Can't ever divorce them. 1 construct, 2 actual variable terms in the model. Questions at all so far? Are we good? Yeah? All right, what's the last thing I got to do? Create a moderator term, right? Now, to create a moderator term, you multiply predictor 1 by your moderator. So we have to do that. We have to multiply income centered by industry. But how many industries do we have? 2, right? 2 variables. So same thing with our moderator. So we have to multiply income by J1 and income by J2. Tedious, maybe was the word I was looking for.
Why don't we center the outcome?
We never center the outcome, right? We don't want to center the outcome because then we're predicting centered outcome values, not actual values of Y, right? It would mean that the Y-axis wouldn't give you, actually, if you were trying to predict a value, you'd be predicting centered Y values. I'll offline. Are we good with the moderator term? Questions at all about this? So you can see it's conceptually no different. You now have a lot more terms in your equation that you have to handle, right? So whatever the word tedious is with a slightly more positive connotation. What?
Nuance.
Nuance. Thank you, Brady. It's more nuanced. Good. It's much better. So here's our data. This is the same. It's not revealed. All right, here's our equation. Let's look at the different pieces. This is why I color coded, because you actually still only have 3 pieces. You did with continuous. It's that each piece has more than one term in it. So let's look at these. You've got the pink, which is still, is there a main effect of income on quality of life, right? Then you've got the green. That's what? Main effect of industry on quality of life. And then you've got the red, and that's what? The interaction. Good. How do we talk about the interaction? Well, do income and industry interact to affect quality of life? Or let's be more specific here. This is the generic math version, right? I want us to get better at the storytelling. And in order to get better at the storytelling, we can't be, that's the interaction. We have to actually contextualize what the interaction is. We can't contextualize the interaction without a what? Theoretical model. So there's our theoretical model. Industry is operating as our moderator, which means this term is actually saying, does the relationship between income and quality of life change based on industry? See how that's different than saying, do they interact? Yes, are we clear on that? Right? It's contextualize versus decontextualize. The more you can practice contextualizing that way, the easier storytelling gets at the end. Questions about this? Questions online? All right, so model fit looks exactly the same. Here I ran 2 models. What's in my first one? Main effects. What's in my second one? Main effects and the interaction, right? So we've got model 1, 79% of the variance in quality of life explained. Model 2, 82% of the variance. Change is an additional 4%. That change is significantly more. So here's how I talked about it. Oops, not that. Model 1, which tested the main effect of income and industry, was significant, explaining 63% of the variance in quality of life. Model 2, which included the interaction between income and industry, explained significantly more variance, suggesting that the association between income and quality of life varies by industry. Notice that last sentence is written in a very specific way. How did I write it? It's in line with something. What? My research question and my theoretical model, right? I could have, it would have been accurate to say, suggesting that income and industry interact to affect quality of life. That would have been factually accurate, right? That does not theoretically align to the fact that I'm conceptualizing industry as my moderator and income as my predictor. Right? I'm purposefully talking about it in alignment to my research question and my model. That makes sense? It's not wrong to say they interact. Statistically, that's accurate. I'm storytelling always along the way in alignment to the research question, which is, does the effect of income on quality of life depend on industry? Cool? All right, are you ready for the nuance? These next 10 slides are basically the rest of the lecture, and they are the nuance. My new favorite word. You don't know what I mean when I say, guys, we're gonna learn something nuanced. We're gonna go through all the coefficients. You're gonna have to revisit this and practice this. The cool thing is everything I'm gonna go through here, you actually know, right? It's putting it together and thinking your way to it. It is not, if you are hoping to look and be like, I know what that is and I'm gonna memorize it, forget it. This is not a memorization game because you will trip you up. You've got to think your way through it. So I am showing you this. I'm modeling thinking through it instead of giving you the definition. Okay. So question online.
Hi, Dr. Diaz. I have a quick question. So when we are writing the results section, we shouldn't specify which industry is better or worse. We should generalize it.
You don't know yet. We haven't looked at the coefficients. This is model comparison. Now we're going to interpret the whole coefficient table. You don't know anything yet, right? Yes, we're now about to learn all of these, and then you're going to know a lot more about the differences. This is where it gets trickier. I'm going to model thinking through it. We're going to go through each number in this table. Well, we're not going to go through standard error and T and P because we know how those work. We're going to go through the B's and betas. All right, starting with this blue box. That is the what? The intercept. So if we knew nothing about anything and we regurgitate memoried, the intercept is the predicted quality of life when all values are 0. Cool? All right. So plugging all values, plugging 0 into every variable means something different for continuous and categorical variables. Let's start with continuous. What does it mean to plug in a 0 that's centered for income? Average income. Good. What does it mean to plug in all zeros for a categorical variable? Good. So what is this number actually? It's the predicted quality of life for someone with average income who works in agriculture. See, you can think your way to it. Now, let's think our way to it visually and with the equation. Ready? Here's our graph. We're going to graph it. We're going to graph every value after looking at the value. So here's our graph. I made a little reminder that the 0, right, is actually x-centered equals 0, which means it's average income. So here's our equation, and I plugged in zeros for every variable. Cool? So 2 things to remember. Remember that a centered value of 0 equals average income. And, whoa, it's the reference group. So what is the only thing we're left with? 74.58. That is the intercept for the agriculture group. Got it? Ready for the next one? All right. Pink. Ready for the next one? All right. How do we interpret this if we were robots? This is the slope between income and quality of life when the other variable is average. Right? Remember, it's a moderation, so it's not holding constant. It's when the other variable is 0. Has to be, right? Because otherwise, the moderator term is going to change it. So let's do that. The slope between income and quality of life when industry equals 0. Wait, industry equals 0, which is average, is not a thing if it's categorical, right? So it's when it's agriculture, the reference group. So this is the slope between income of quality of life for those in the reference group, agriculture. Let me show you why that is with the equation. Here's that 0.26. I put in zeros for everything else. What happens to all of these terms? They go away, right? So 0.26 is the slope between income and quality of life only when we plug in zeros here. And what does it mean to plug in zeros here? Reference group. So that's the slope between income and quality of life for the reference group. Looks that. You can do B of 0.26 or beta of 0.30. As I said before, I much prefer dealing with betas when it comes to slope because I can visualize it. But I put them both on there so we don't forget they're the same thing. Cool? Are we good? Online? That's a big thumb, AJ. I mean, like, keep that perspective on the camera, not your actual thumb. All right, now we've got J1, unstandardized 5.28, standardized 0.575. Here's where it gets fun. How do we literally interpret this if we were robots? The same thing we always. For a 1-point increase in J1, we can expect a 5.285 unstandardized increase in quality of life, assuming income is 0. Cool. A lot of the things I said don't contextually mean anything. So first of all, what does a 1-point increase in J1 mean? From reference group, which is 0, to a 1 in J1, which is technology. Then we can expect a 5.285 unstandardized increase in quality of life, assuming income is 0. What does income of 0 mean? Average, right? So I'm going to actually go backwards here. Watch what happens here. Only happens with categorical variables. I plug a 1 into J1. What does this term become? A constant, a number, right? It's not a slope, it's a number. So where can it go? It can only get added to the intercept. So watch what happens. 5.29, you end up with an intercept, a starting point that is higher than agriculture started. And it looks that. Tech starts 5.29 points above agriculture. So going back to the last slide, it's actually a change in intercept from agriculture to technology. Individuals with average income in tech are predicted to be 5.285 points higher in quality of life than ag workers with average income. So remember, here we have average income. So if you're somebody here who is, if you are saying, I've got people who make average money in their industry, if they're an ag worker, they're predicted to be here. And if they're a tech worker, they're predicted to be 5.29 points higher.
Is it average money across all industries or across their industry?
Average money across all industries, right? Because, and you know that, you can tell me why.
All
Correct, exactly. Because we centered with one mean, right? Yeah, it's not group centered, it's grand mean centered. You can, in other types of analysis, not here. Ready for the next one? All right. Second one, same exact concept here, right? We could interpret it as for 1 point increase in J2, we can expect a 10.05 unstandardized increase, assuming income is 0. That's the literal interpretation. What that really means is it's a change in the intercept again, right? The quality of life for individuals in government who make average income is predicted to be 10.05 points higher than agriculture workers with average income. Let's look at how that happens. So here we plugged in a 1 for J2. What does that become? A constant, right? This term doesn't get applied because it's a 0, right? They're a 0, 1, they're a gov worker. 10.5 gets applied to the intercept with a starting intercept of 85.08 for gov workers. They start here. Brady.
It's no particular, may not matter. When we think about the expected change in quality of life for average government workers, or average income for government workers versus average income for ag workers, we're not referring to the average income of government.
No, that's what
Yeah.
Emily asked. It's the average of the sample.
It's the global average, right?
Because we grand mean centered, right? We subtracted the mean of the whole sample from everybody's income when we centered our data. We didn't subtract the mean of each industry. There's the fun part. We're through the first one, and we're through both main effects. Now we get to the fun stuff. All right, moderator. Now I'm going to start with the literal interpretation and then get to how do we contextualize that. So we know that moderator terms are what? They're not slopes. They're change in slopes. So all moderator coefficients are changes in slopes. Cool. So here's how we would interpret it. Now, remember that moderator terms are interchangeable, right? They're income times J1 or J1 times income. So I have to decide when I'm interpreting whether I'm going to say for a 1 unit increase in income, this is how the relationship between J1 and quality of life would change, or for a 1 unit increase in J1. How am I going to choose?
Based on your model or research question?
Model and research question. Which of the things, predictor or moderator, is the one I want to refer to as the 1 unit change? The moderator, right? I'm interested in what happened to the core relationship as the moderator goes up or down. So I always want to say, as the moderator increases, this is how the slope changes. So here, as J1, if I were going to interpret this literally, it would be for a 1 unit increase in J1, we'd predict the slope between income and quality of life to go down by 0.38 unstandardized or 0.28 standardized. Cool? Everybody get that part? Questions about that part before I go to conceptual. So now let's actually look at it, what happens. Let's start with conceptual, unstandardized, and we'll do standardized. So this is the change in slope between income and quality of life as we move from ag to tech, right? So we've got income, quality of life, and we're seeing how much is happening. How much is that original slope here in yellow changing when we move from a reference group to J1, which is tech. Now, well, we have to know, well, where are we starting, right? So what's the unstandardized relationship between income and quality of life for the reference group? 0.26. Y'all see it right here, right? And what is it standardized? 0.30. So that's where we start, right? The unstandardized slope between income and quality of life for the reference group is 0.26. When you move to tech, that 0.26 goes down by 0.38. That leaves us with an unstandardized slope of negative 0.12 for the tech group. We can do the exact same thing standardized. Starting standardized slope between income and quality of life for the reference group is 0.3. When you move to tech, so you go up 1 unit in J1, that 0.3 decreases by 0.28. That results in a standardized slope of 0.02 for the technology group. Let's look at what that looks on the graph. I'm going to use the betas here because they're easier to visualize. So I'm plugging in a 1 for J1 in my moderator. Why? What does that represent? Yes, what does that represent in the interpretation of a moderator term? That's my 1 unit increase in J1, right? So for a 1 unit increase in J1, right, this resulting term is going to be negative 0.28 what? What does this term become if you simplify this whole thing right here? Do you know how to multiply one by one? We know how to multiply by one. Negative 0.28 income, right? It's a variable. It doesn't go away. So if we have 0.3 income over here and negative 0.28 income over here, we can combine those terms and look what happens. 0.30 income minus 0.28 income, and we're left with a slope of 0.02. There's the slope for tech, okay? So it's negative 0.12 unstandardized, 0.02 standardized. Good so far? I told you, nuance, just a lot of pieces, thinkable. Plug your ones or your zeros.
Picking up an assumption, assumptions wise, verify multilinearity. So I couldn't guess what industry they're in based on their income and the status then.
That's why we set our income.
That would have
Yeah.
been, that's what I
Enough.
thought would be, if all the tech workers make $1 million and all the agriculture workers make $20,000, can I still run this?
Makes $20 million. Yes, you would end up with probably with homoscedasticity issues.
I have a clarifying question based on that. So we don't really care about what they start at, though. It's really the relationship between
Correct.
and the quality of
Correct.
life. So it doesn't really matter.
Correct.
Why
Good. That's a good question. So a couple people have asked now about, oh, this is these intercepts are the predicted quality of life, right? When income is average for each of these three groups, right? The income is average is global average. Yes, that's informing the whole equation. That's not our focus, right? That's not our research question. Our research question is what's the relationship between income and quality of life for each of these groups, right? So it's not the fact that we global mean averages and that we have three intercepts is giving us the correct equation. It's not our focal question.
Can B and the beta be in different direction or? is
Yes,
that-
they are in different directions. So yes, they can. What does that mean? Well, they're totally different units, right? So it doesn't matter that they're in,
Direction.
no. And especially not when what? What do you suppose about this line right here? Exactly. All right, so we've got tech. Last line, here's the last one, right? This is another moderator term, so it's a change in slope. So if we want to literally interpret this, we would say for a 1 unit change in our moderator, which is J2 here, we'd predict the slope between income and quality of life to go down by 0.54 unstandardized or 0.29 standardized. So we're starting again, still at 0.26, right? That's that starting for the reference group. When you move to government, that 0.26 goes down by 0.54, which results in an unstandardized slope of negative 0.28, okay? Standardized, we started at 0.3. When you move to government, that 0.3 decreases by 0.29, which results in an unstandardized slope of 0.01. So same concept, we plugged a 1 in for our moderator J2. We end up with negative 0.29 income. We can combine it with our starting slope and we end up with 0.01 income. Or if we did it up here, right? We did 0.54 income and we added it minus 0.54 income here, right? We would get minus 0.28 income. And there it is, right? Why are they so different? Because the standard deviations are different of the raw data, right? If you look at the way the data were measured, they weren't measured in the same units. So 0.28 looks wildly different from 0.12. They're actually not wildly different because they're in wildly different units, right? That's why we care about betas and not these. One was measured in 110, one was measured in 1 to 100. So here we are with our 3 lines. There's not really, I can ask, are there questions? It's sort of one of those ones where you have to go through it a few times, right? To be like, yes, I get how that changed the intercept. I get how that changed the slope. We're going to do this exact same example from a different perspective, which is the equations. Sometimes people get it from doing coefficients to graphs. Some people get it by the equations. We're going to do both. Yep.
So we did play terms, and that's why we have to run income, and income is not 1 for every 1 income.
Nope. So how do you interpret a slope? For every 0.01 standard deviation increase in income, quality of life is going to go, for every 1 standard deviation increase in income, quality of life is going to go up by 0.01 standard deviations, right? Which is really small, right? As we go up by 1 standard deviation, quality of life is going up by not even a tenth of a standard deviation, right? Tiny, which is why the line is virtually what? Flat, right? So here are our equations. We're going to look at these equations again in a different form, right? We've got 3 different intercepts with 3 different slopes. We also look at the standardized equations, right? When we're talking about the reference group, there's no intercept, right? Remember we had those J1 and J2 right here, right? Even in the beta version, even in the standardized version. So in these standardized versions, we still have changes in intercept. What do those mean? They're standardized values also. So for the government group, what does a 0.9 intercept mean? It's almost they start almost one standard deviation above where ag starts. Exactly, right? Again, not our focal question, right? When you're looking at that and going, what does that mean, right? That's what that means.
It's kind of an interesting part of the story. Well, if you had 3 people who started in different career fields, all made the average income.
All made the same amount, average, yep.
All have made the same amount.
Yep.
The ag worker would have loaded quality of life increase over time.
Yep.
Increase over income.
That's right.
No point in making more money if you're working in tech or government.
Correct, exactly. It seems you might actually still stay slightly happier if you work in government, maybe not now, right? So here's a question. What's a simple slope in the context of this research? Let's start with that question. What is a simple slope? What's a simple slope here? First of all, how many do we have? 3 simple slopes. What is one of the simple slopes? The relationship, say it loud.
Between income and quality of life for agriculture.
Perfect. When you are describing a simple slope, it should start with a relationship between a predictor and an outcome, and it should be what? At a certain level of your moderator. When you're dummy coding, it's going to be or categorical moderator, it's going to be one of your levels. When it's a continuous moderator, it's going to be when that moderator is high or low. Do you think the simple slopes analysis would reveal significant slopes here? For which one? My hunch here is that the slope between income and quality of life for agriculture, so the yellow line, would probably be significant and positive, right? A 0.30 slope, right? So for agriculture workers, as income goes up, your quality of life increases. For tech workers and government workers, it seems to be flat. You do need to look, you can also look at how high they are, right? So what's interesting is as you make more money as an ag worker, your quality of life goes up to a point where you actually meet the quality of life of government workers. Potentially exceed, we don't know how far income goes. Okay. Let's look at another way of thinking through what those coefficients mean. If you are somebody who has a tendency to memorize, these next 2 slides are a way to get out of the memorization game because memorizing will kill you with moderation. Your whole equation is your model. Got it? That's your model. You can figure out all of the things you need to figure out by manipulating this model, right? So here we go. We're going to start with it. We're going to do unstandardized and standardized. For agriculture workers, let's start here. Here's the whole equation. What does it mean to be an agriculture worker? What's your dummy code? 0, 0. So what am I going to do? I'm going to plug in zeros for J1, and I'm going to plug in zeros for J2. This is going to be one of those ones where you want to follow along rather than note take because I'm going to cross out things as I go. So I've plugged in 0 for everything, right? Agriculture workers, so they get a 0, a 0, a 0, a 0. So that whole thing goes away. What am I left with? An intercept and a slope. That's the whole equation. Now, let's do it for tech workers. What am I going to do for tech workers? Plug in a 1 everywhere I see what? J1. Here's 1 and here's 1. First thing that happens, those 2 things go away, right? Then I end up with this 74.58 plus 0.26 income plus 5.29 minus 0.38 income. I've got 2 numbers. Here's a number, here's a number, and I've got 2 slopes of income. Cool. I can combine the yellow and I can combine the blue, right? And I end up with 1 intercept, 1 slope. Okay? Same thing for government workers. Start with the whole thing. Plug in plug in a 1 every time you see J2. Get rid of the terms that go away. Anytime you multiply 0, everything goes away. You end up again with 2 numbers and 2 slopes of the same XY relationship. So combine the terms, yellow goes together, blue goes together, and you get the equation for government workers. And what's the difference? So here's the slope is 0.26. Here it's negative 0.12, and here it's negative 0.28. The difference between these 2 is the moderator term, 0.38. The difference between these two is the moderator term, 0.54, right? Those are the changes in slope from the reference group. So now, if you want to put it all together, cool idea, this first part is always going to be the reference group stuff, right? Because everything else has what in it? What does it have? It's got dummy codes in it. J1, J2, J1, J2. So if we're talking about the reference group, all those terms are going to go away. So in a dummy coded moderation model, in a categorical moderation, that first intercept and slope is always going to belong to the reference group. Then these next two that belong to the dummy code, they're going to change the intercept. And the last one, the red, that's going to change the slope. Cool. You do the exact same thing if you want with the standardized version. For ag workers, you put zeros in for everything. Guess what? You end up with 0.3 income. That's it. Now, why do I have Y standardized? Because you're predicting standardized values of Y now, right? Not predicting raw values of Y. You do the same thing for tech. You put a 1 in to represent tech. You end up with 0.3, 0.58. You can combine these two. Now you have a new thing. You have a number for the first time, right? So you get 0.58 plus 0.02 income. Same thing for Gov. Plug in a 1 for Gov. Cross out your zeros that go away. Here you have two slopes of income. One is the original, one is the change, and you have a number value, and you're left with a standardized equation. Same idea. First part belongs to the reference group. Second part changes the intercept. Third part changes the slope. What's our interpretation? Industry does moderate the relationship between income and quality of life. There seems to be no relationship between income and quality of life for tech and government workers, a significant positive relationship between income and quality of life for ag. Or you could say the relationship between income and quality of life depends on industry. For ag workers, the more money you make, the better quality of life. For tech and government workers, there seems to be little effect on quality of life. If you wanted to add more of the story of like where people start relative to each other, you totally could. Okay, cool. Yes, Jason. Well, it depends it depends what you think it's not necessarily. If you added a continuous variable that you're only hypothesizing a main effect of, right? Again, it depends on your research question and your model, right? So when we do path analysis, you're gonna have models that look like this. Oh, not that, right? When we do path, you can totally have models that look this, that are moderated that, and you have another predictor that looks this, and maybe you have another one that looks this. You can have as many as you want. You're talking about one that would have moderators on here. Depends on what you're theorizing. Yes, all of those things are possible, and yes, you could end up with a lot of moderator terms. Try structural equation modeling. Then you can have, I don't know, 50 moderator terms. It's really fun. All right. I want to do one more thing on the slide deck, not until we take a break. So it's 10.
Can we go back to slide 25? So for standardized
Can you
equation,
tell me what slide? Oh, hold on. I can go.
standardized equation. So if we were to graph the first one, would my y-intercept be down at 0, 0?
If you're no, it would be more that this axis would change. So the lines wouldn't change. What would change, and the points wouldn't change. What would change is that this point would be 0, and this would be plus 0.5 SD plus 1 SD minus 0.5 SD minus 1 SD. The scaling of the axis would change.
Oh,
One of the challenges coming out of high school algebra into stats is that we're so used to this origin being 0, 0, right? And actually you can move axes up anywhere on, it doesn't have to be at the origin to be 0, 0.
Thank you.
So that remember, the values themselves aren't changing, right? If you're in my sample V, your scores don't change. All I'm doing is changing how I describe your income. So instead of saying you make, this much money, I'm saying you make this much above the mean or below the mean. So I'm scaling the axis differently.
Thank you.
Good question. All right, it's 10:20. Let's come back at 10:30. I'm gonna start at 10:30. So come back at 10:28. Can we do that? Pinch me, I'm running. The what? Rainbow racer? All right, I should dress up when I run. For races, not for regular, to be clear. Because I didn't make things fun or confusing enough. Let's level up. Sound fun? Yes, Ray.
Yes.
Of course.
Go back a couple slides to when you were doing all the. I think so. The reasons why I didn't.
Yes.
Standardized, the tech workers and the government workers have a negative slope compared to the standardized, they're really close to flat.
Yes.
Why negative?
So it doesn't go from negative to positive. Remember that it's in standardized, it's in unstandardized versus standardized units. So unstandardized, and it also doesn't account for the amount of error in standardized or unstandardized units. So here you have, is this unstandardized? Negative 0.28 on a scale of 1 to 100 with error is basically flat. Does that make sense? Right? Negative 0.28 looks, oh, 0.28, and it's negative. You're talking about a 1 to 100 scale. And also remember, this is centered, right? So it's below, it's just basically flat, right? It's no different than 0. So the fact that it's negative is noise, right? From the error. It's, and I think it's really important to understand, it's not switching, right? This B is equivalent to this beta, right? The negative 0.28 is the raw value, right? And this is the standardized value. Because it's not significantly different than 0, that's why you're seeing the sign change. You wouldn't see the sign change if the slope was significant, right? Because if the slope were significant, meaning it was actually going up for a one standard unit, for a unit increase, then it would have to go up in both ways. If it's flat, it can be hovering around flat either way. Yep, good question. Does that answer your question?
I think you basically answered, because I was wondering kind of what they were, Ray and AJ were asking us, the shift is that to indicate that it's not sitting value.
And remember, it's not a shift. Careful, it's not a shift. 0.02, 0.01, and negative 0.28 are hello and hola. They're the same thing. They're in different languages, right? One is in standardized language, one is in unstandardized language. They're basically both flat, right? They're hovering around flat with noise. They're not different. The slope is the line. If you think about how we visualized it, right? It's one line with both slopes written on it, right? It's the same slope. Okay. Oh, yes.
Why is not significant?
Because because what we're testing when we test simple slopes is whether this B or beta, so the null hypothesis in a simple slope, is whether this simple slope is significantly different than 0. And given a beta of 0.01, it's not going to be significant. Good. We don't have the actual data to support it here. It's so flat, I can virtually guarantee it's not going to be significant. And that negative versus positive difference between the B and the beta also suggests not different. The other thing to think about, Ray and JJ, is that remember that in the unstandardized version, you have this giant 74.58 that's getting added, right, to get your predicted Y. So even though you have a negative slope here that you're starting with, that's part of the offset too. Let's level up. There's one of these on your DAs. This is one of your, do I really understand how these coefficients all work together? It's taking the same exact skill, or I should say the same exact knowledge, and manipulating that knowledge in a different way. Some of you hate this. If you give it to me in the exact same way, I'm good. If I have to manipulate it, it's hard. So this is a practice with manipulating the exact same thing we did in a different way. Not that. An educational researcher replicated a portion of a study examining how SAT predicts University of California GPA based on various demographics. In their examination of family ed background, they examined first-generation college students, dummy-coded 1, versus non-first-gen students, dummy-coded 0. Using the following information, create the regression equation predicting UC GPA from SAT scores as moderated by family educational background or first-gen status. You're working backwards here. You don't have coefficients. You got to make the coefficients. So what's the very first thing I'm going to do here? Probably. What? Draw a model, right? Because I want to orient myself around what's my predictor, what's my moderator. So what's my outcome? That's easy, right? First, I'm going to label my reference group just so I remember, right? Non-first gen is my reference group. Then I'm going to draw my model. GPA is my outcome, SAT is my predictor, as moderated by first gen status. So my research question is, does the relationship between SAT and GPA depend on whether somebody is a first gen student or not a first gen student? Good so far? What would be the next helpful thing to do? Draw the skeleton of the equation, right? You're going to have to end up with an equation, so we might as well remember what terms have to go in there, right? What are we gonna have to figure out? Well, we know we have an intercept, right? We're gonna have to have a slope here, right? We're gonna have to have a slope here, and we're gonna have to have what? A moderator, a change in slope. Now, how many levels of our categorical do we have? How many levels of our categorical do we have? 2. So do we need 2 dummy coding terms? No, this one's a little easier. We only need 1, right? So we're gonna have an intercept, which is average GPA. So how many terms is this equation gonna have? You can count 4, right? Here's our standard equation, right? Our standard equation is y equals intercept plus b1x, b2z, b3, x times z. There's our skeleton, right? Now all I'm gonna do is swap my x and z's for my actual variables here. What's my x? SAT score. What's my z? First generation. Great. So there's my equation. Good so far? This is all set up to orient myself. It's not the hard part, right? Now let's do the fun part. So there's the equation that I came up with, right? And somehow we have to do what? We have to put coefficients in, right? For B1, B0, B2, and B3. So let's start with what would happen. So non-first gen is the reference group. So they're coded 0, right? And first gen is coded 1. So if we plugged in a 0 everywhere we saw FGS, that would represent non-first gen students, right? See that? And what would be left? Just this part, right? So B sub O would be their predicted GPA, right? When SAT was average. And what would B1 be? The slope between SAT and GPA for who? For who? For the reference group, non-first gen. Do we have both of those pieces of information?
Yeah.
Yes. So we have the first part of the equation. Y equals 3.20 plus 0.37 SAT, right? Because this is what it would look like if we plugged in a 0 for FGS, signaling the first gen group. Now, we have to figure out B2 and B3. Here is what is tempting to do. Plus 30 FGS minus 0.10 SAT times FGS. What's the problem with that? Now when I plug in a 1 here, what's going to happen? The GPA is going to become 6.2. Is that what their GPA is? No, their GPA is 3. So what do we actually need to find? We need to find the change in intercept. So how do we get from 3.2? How do we get from 3.2 to 3? Subtract 0.2. So then we've got y equals 3.20 plus 0.37 SAT minus 0.20 FGS. And then how do we get from 0.37, right, which is the slope for first gen, non-first gen, how do we get from there to negative 0.10? How do we get there? Subtract what? 0.47. Here's your equation. So this is the information for the first gen, right? This is the line for non-first gen. This is the line for first gen. The single equation has to give us the change in the intercept and the change in the slope, right? How does it do that? Well, we went through the 3 parts, right? When we have a categorical predictor, this is the change in the intercept, and this is the change in the slope. Cool? You get to practice one of those on your DA.
Conceptually, would this then say that for first generation students, SAT is either not related, because we don't know the significance level, or negatively related?
My hunch is not related. Exactly. If that negative 0.10 were not significant, then it would mean for first gen students, there's no relationship between SAT and GPA, which is what I would suspect, which is why a lot of schools stop using the SAT. Well, that and other reasons. All right. Want to see this in a demo, right? The demo is very close to what we've been doing the whole time. There's not a lot of newness in the demo at all. There are 2 demos for you to look at. There's a continuous one and a categorical one. I'm gonna start with the continuous demo. Why is that? Hold on. All right, so here's our continuous moderation. It's gonna follow exactly what we did. The code for our models is gonna be exactly the same, right? Our assumptions are gonna be exactly the same. The only code that's gonna be new is creating a moderator term. That's new, and graphing and doing the simple slopes. That's it. Everything else is old code. It's multiple regression code. So you are a positive social psychologist studying the effect of burnout on positive coping strategies. So burnout is our predictor, positive coping outcome. Your past research demonstrates that more burned out an individual is, the less they're able to exhibit positive coping strategies in the face of challenge. However, you've noticed that this isn't a consistent reaction. Some individuals seem to be more resistant to burnout's impact than others. You have a suspicion that personality, specifically extroversion, may play a role in this difference. You decide to test this hypothesis. So what's our moderator? It's extroversion specifically. So we're not looking at, this is not a categorical. We're not looking at introvert versus extrovert. We're looking at level of extroversion. And we're looking at whether the level of extroversion moderates or changes the relationship between burnout and positive coping. I'm reading in the data. Notice it says DTA. You see that? It's just a different format of data file than what you're used to. So I'm using Haven package and the function read DTA. Fun fact, you can read almost any type of data into R. So if you have an SPSS file, you can read it into R, right? If you have a DTA file, you can read it into R. You can read anything into R, okay? If it's not working, it means you probably don't have Haven. So install Haven real quick. And then I'm making all of my column names lower because that makes my life easier, all right? So here's our data. We've got extroversion, neuroticism. You could test the moderating effects of neuroticism. This would be a great data set to now go run a couple other moderations by yourself for fun to practice, right? You've got other moderator models in here you could run. You've got neuroticism, you've got burnout, you've got positive coping, you've got negative coping, and you've got anxiety. You've got a bunch of different variables in here that you could practice moderated models with. What else do you notice in here that's kind of annoying? Missing data. That's gonna mess with our model. I'm gonna run my descriptives, and what I notice right here, I've got missing data. It's not a lot, and look at my N. Do you see that? That's huge. So I'm just gonna get rid of them. I'm gonna list-wise delete them, right? Here we go. NA.omit, just as a fun added thing, because this data set happened to have missing data. NA.omit means get rid of any lines that has missing data. So go ahead and get rid of it, and I'm going to rename a new data set. For the sake of time, I'm going to skip our assumptions because they are the exact same code that we have been running for simple regression and multiple regression. Scatter plots between your predictors and outcomes, correlation tables, homoscedasticity, fitted residual plot, Roush-Pagan test, multivariate normality. That's it. Same as always. Got it? All right. Now let's prep. What do we have to do to prep? Center our continuous predictors. Both of our predictors are continuous here, right? Extroversion and burnout. So here's how we center. We take our variable, we subtract the mean of that variable, and then you see this right here, rm.na equals true. We actually don't need that because we don't have any missing data. If we did, right, we could use this term to be when you're calculating the mean, skip over missing data. We don't really need it. It's going to give us the same result here because we don't have any missing data. And I usually name my variables burn.c and extra.c so we remember they're centered. And those are going to go at the end of my data set, burn.c, extra.c. What's the next thing I need to do? Everybody, what do I have to do next? Create a moderator. I'm doing moderation, right? So how do I do a moderator term? I literally multiply, right, my two centered variables. So I've got burnout predicting positive coping, and I've got extroversion moderating. So I need to create a third term, which is burnout times extroversion. Okay. How do I do that? Very simple. I say create a variable. That's $ means variable. I'm going to call it mod. That's not very exciting. It'll work. And what do I want to make it? I want to make it that variable times that variable. It's a very simple operation. That asterisk is the R symbol for multiply. Question. Run it, and you have this mod term over here. Why is it all weird numbers? Because everything's centered and because they were weird values. All right, now what are we gonna do? Are we ready? What do we have to do? Hello?
Create your models.
Yeah, create our models. Guys, wake up. We only have 10 minutes. Come on. We got to specify our models. So let's start over. We've got a model, right? Burnout on positive coping, moderated by extroversion. What's our research question? Does the relationship between burnout and positive coping depend on extroversion? We read in the data, right? We checked our assumptions, theoretically, right? We centered both predictors. We created a moderator term. What else is there to do? Run the models. So what's our first model going to be? Main effects, right? So here we have the same exact code we've used for multiple regression, lin-reg. Dependent variable is pos cope. We're going to use burnout, extroversion in our moderator term. First model has burnout and extroversion in it. That's our made effects model. Second model is going to add moderation on top of that. I'm going to test those models together, and that's it. Let's run it. Here's model one. It explains about 12% of the variance. So the main effects explain 12%. Main effects and the moderator explain 13%. It's not a huge change. It's significant. So in this case, we can actually, in a multiple regression, we often to look at all the models, even though there's a best model, right? Because we want to see how things change. Here, we're really looking at main effects versus moderation. So we can go ahead and go look at our moderation level here. And what do we see? The very first thing that I'm going to do here, almost always, y'all, this is what I would do if this were my own data, is I'm going to put these betas on a figure and annotate. Because that is the easiest way for me to figure out what's going on. And I'm not telling you that, oh, you should do this, but this is literally what I do with my data.
Recording in progress.
Okay. So I'm going to draw. Here's burnout. Here's pos coping. Here's extroversion. And I've got my main effect in there too. I'm literally going to take my betas and I'm going to annotate this. So the relationship between burnout and positive coping when extroversion is average is negative 0.34, p less than 0.001. So as burnout goes up, positive coping goes down, right? When extroversion is held average, right? That's the main effect. For extroversion, the beta is 0.09 and the p is less than 0.001. So as extroversion goes up, positive coping goes up a little bit as long as burnout is average. Now let's look at that change in slope. Extroversion, the change in slope is 0.11 and the p is less than 0.001. So as extroversion goes up, right, it's going to come in and hit this starting slope, right? As extroversion goes up by 1 standard deviation, it's going to come in and it's going to change the slope by positive 0.11, right? So when extroversion is average, burnout to positive coping is negative 0.34. When extroversion goes up 1 SD, the relationship between burnout and positive coping changes by that positive 0.11, right? And we get what? 0.23, negative 0.23. So what happens when extroversion goes up? What happens to the slope?
It moderates the relationship between burnout and pos coping.
How? What happens to the slope?
It increased the slope.
Can we compare 0.34 and 0.23? So what happens to the slope when extroversion goes up? It decreases, right? It gets weaker, right? It gets weaker. That's a buffering effect, right? Because we're talking about the effect of something bad on something good, right? We're, oh, this bad thing hurts this good thing, negative 0.34. It hurts it less when extroversion is high. Now, let's look at what that looks graphed. If you're having trouble with R with packages, follow along because you'll miss the actual learning part over the tech part. So let's look at those actual simple slopes. So we can run them 2 ways. You can run them unstandardized if you want to know the unstandardized simple slopes, not super helpful. Or if you want to know what the slope is between burnout and positive coping when extroversion is high and low, you want betas, you can run it standardized. Here are the 2 ways to do that. This is new, wasn't in last year's if you want to run them with betas instead. We're going to use the same code with 1 different addition for standardized. The first one is unstandardized. You're going to need these 3 packages. Again, if you don't have them, I would watch, take notes, and do it later. The first thing you have to do is fit the model. You can use your raw variables. You don't have to use your centered ones. Linear model, pause coping is the outcome, regressed on, burnout times extroversion. Do you see that? Why don't I have to have the main effects in there? Because linear models know that when you have an interaction, you also need to include the main effects. It's automatic. Also, we're going to be looking at simple slopes, so it's going to model the simple slopes for us. The model I'm calling it is model.pauseComp. Then I'm going to run the function simSlopes on that model, and I'm going to give you the predictor and the moderator. So this is where I'm theoretically identifying, right? This is where I'm doing the theoretical work. This does not tell simple slopes which one's functioning as the predictor and which one's the moderator. This is, right? I'm telling it which one's my predictor, which one's my moderator. I also want it visual. So I'm going to use the function interact plot and I'm going to predict it. Okay. Here's our outcome graph, right? So you can see here's the mean and exactly what I showed you on the notability on the iPad, right? When extroversion is high, it's still a negative slope. It's not as steep. You see that? That solid line. The question is, are they all negative, right? So if they were all negative, what would that mean?
Extroversion can help, but doesn't really defeat the relationship between.
Extroversion can make burnout have less of an effect. It does not completely erase the effect, right? Doesn't make it flat. So we can look at our simple slopes. Here they are. It's very nice. So this is it when extroversion is low, when extroversion is average, and when extroversion is high. And what we can see is they are all significant, right? Meaning they're all negative. Be very careful. These are not standardized. Those are B's, not betas. Okay, JJ, to your very earlier point, that negative 0.22 matches the negative 0.22 in the regression coefficient table. Okay, now, if we want them standardized, we have to add one line of code. Here's that same model. You don't actually have to run it again because we already ran it. I added one line here, which is standardize the model. So after I generated the model, I standardized the model. That's going to mean that every coefficient that pops up is automatically already standardized. When I run it, what happened? What'd you do? Things wrong before. Yours ran fine. So weird. I'm not gonna run it all. I run when I need to. Your guys' is all ran, right? What's up? All right, we'll look at your screens because I don't know why mine's not working. They're gonna be the same. They'll be the same p-values. And the graph will look exactly the same. Two things will be different. Instead of betas, instead of B's, you'll have betas. And the axes on your graph will be different. They'll be in standard deviations instead of raw values. That's it.
Why does it not matter that we don't center when we're talking about simple slopes?
Because it's still going to run, it's running the interaction. It's not predicting actual values. It won't be any different.
Okay.
You can run it with centered. It'll be the same graph.
Okay.
Cool. You guys want to see a categorical one? If you have to go, you can go. I'll do a categorical one. All right. Before I switch to this, because some people will have to go to 11. I'm going to talk to the people online right now. These people online. Thursday, we're having a practice day. Right now in chat, I need you to tell Allison. Allison, are you online? Quinn, I need you to tell Quinn if you are going to be in person or online on Thursday. If you live in a different state, you don't need to tell Quinn anything. I know that you'll be online, unless you're someone, Lisa, who occasionally randomly flies places and surprises me. If you live in California and you sometimes ever come in person and are sometimes online, please let Quinn know right now. The same thing is true now. I'm talking to all you in the room. If any of you think you will be online on Thursday, I need you to tell me today before you leave, because Thursday is an all practice day and everything gets pre-planned by group. And if people aren't where I think they're going to be, it gets super thrown and we're going to lose time Thursday morning because I'm going to have to shuffle. So please, 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 please. Obviously, if you wake up super sick on Thursday, you can't know that in advance. As much as you can, please tell me. Cool. Thank you. Because I know some people will need to go before I'm done with this. Categorical. All right. Recent studies suggest impulsive individuals may be more vulnerable to cognitive interference from external or internal distractions. This might be me research. This can overload working memory capacity, making it difficult to process and retain information. However, less is known about which types of cognitive interference is liable to moderate this impulsivity effect. This study tested whether smartphone availability moderates the effect of individual differences in impulsivity traits, both positive urgency and negative urgency. So positive urgency with your phone is the idea of, so Heather has her phone on the table, you all do. Heather has her phone on the table. Positive urgency is, I gotta look at it because I might be missing something great. Oh, I wonder if my friend texted or whatever. You're missing out, exactly. Negative impulsivity is what's wrong, what's happening, right? So both types of impulsivity. We designed an experiment in which 132 college students completed a lab task that assessed visual working memory in 3 conditions. 2 conditions differed in terms of smartphone availability. So smartphone turned off on the table was group 1. Smartphone in silent mode and on the table was group 2. And then condition where the smartphone was not available at all, there was a calculator on the table, right? So that's the control condition. And the idea is let's still put something on the table. So you want to make it as close to your treatment conditions as you can. It's not your phone. Okay? This is another one where you can practice the moderation on your own because I've got 2 in here. I've got positive impulsivity and negative impulsivity. We'll do one right now. All right, we're going to read in the data. So we've got group, so cell phone off, cell phone on silent, or control, which I think is called calculator, right? You've got their subject ID. You've got K, which I think is their working memory. You've got SPAY, which is their smartphone addiction inventory score. So they controlled for how addicted you are to begin with on your smartphone. You've got negative and positive impulsivity. Now, we need to dummy code our groups, right? So we've got off, silent, and calculator. What's a good reference group here? Control, right? So we're gonna make our control group calculator 0, 0. And then for the off group, I'm gonna call it condition off so I remember what it is. So it's the difference between calculator and off. And then I'm gonna call my other one condition silent. It's the difference between calculator and silent. So this is our in-class example where we have a dummy coded moderator. It's got 3 levels. So we actually need 2 dummy codes. So again, I highly suggest that you draw this model, not theoretically, also statistically, right? So if you look theoretically, we're talking about positive impulsivity on working memory moderated by smartphone condition, right? Because we had to dummy code stuff, our stat model is a lot more complicated. We actually have positive impulsivity on working memory. And then how did we conceptualize or operationalize smartphone condition?
Later off.
We dummy coded it, right? Our actual variables in our data set are dummy coded. So we've got condition off and condition silent, right? And both of these have main effects, right? You also always have an intercept, right? B. So you can see right here, 1, 2, 3, 4, 5, 6. That's how many coefficients you're going to get in your output, right? Or if they're betas, how many are you going to get? 5, right? There's no original intercept for the reference group, right? So draw these because you should be able, once you can go from, I think one of the most helpful things is being able to go from the coefficient table to this, to the equation, right? And back. I find labeling much more helpful than doing equation and coefficient table. All right, we have to center our continuous predictors. I'm centering all 3 here in the demo, not because we're using all 3 in our model, but because in case you want to play with the other 2, you can. So positive impulsivity, negative impulsivity, and smartphone addiction, we're centering. There are our centered predictors. And now what do we need to do? Create a moderator term, right? We got to multiply our centered predictor by our dummy code, right? You got to moderate, have your theoretical model next to you. You've got to moderate positive impulsivity by smartphone. Where's smartphone in your data? It's right here, 1s and 0s. Here it is for the positive impulsivity. So conditions times positive, and here it is for negative, and then we're ready. We were in the other one. Dependent variables, that's working memory. Here are covariates. It looks a lot. Remember in the PowerPoint, 3 colors, right? Intercepts, or sorry, 4 colors, right? Three terms, main effect, interaction. You have it here. main effect of positive impulsivity, main effect of condition, interaction.
There any utility to building three models, with the first one being impulse, like so you can kind of get those.
It's up to you. The more useful one would actually be to run a first one with smartphone addiction and control for it, but we're not doing that. I'm isolating this skill right now. So the first model's got my main effects. Main effect of positive impulsivity, main effect of smartphone condition. Second one adds in my moderation, and here's our model fit. 6% with main effects only, 11% with the moderator, 5 additional percent variance in working memory, significant difference. So there is a moderation. Okay, let's look at.
Jess, can I ask a quick question?
If
If you're looking at the delta R squared and the only thing that you're adding is the interaction effect and it's significant, I would assume that at least one of those slopes, the simple slopes, has
Correct.
to be.
No, wait, careful. It is not that those simple slopes have to be significant, because the simple slopes are testing at a particular level and testing whether they're flat. What you can assume is that the slopes are going to change. At least one of those slopes is different than when we're talking about a calculator.
So one of those slopes will have a significant difference from the other slope.
Correct. Right? It changes. It means that the moderation is significant. It is changing when you change smartphone condition. So let's look down here, right? Here we've got our slope between positive impulsivity and working memory. So as positive impulsivity goes up, what happens to working memory? It goes down, except no, it doesn't. There's no relationship. Look at that p-value, right? Who's that for? Calculator users, right? So when there's a calculator on the desk, right, there's no relationship between positive impulsivity and working memory. Interesting. Why might that be? Well, maybe because I don't have anything to be impulsive about, right? Then we have our change in intercepts. And then here we have our moderation. So this one's kind of cool. When we move from calculator to off, so instead of having a calculator on my desk, I have a phone that's off, meaning I know that I cannot read anything on that phone. Does the relationship between my positive impulsivity and my working memory change? No. Why not? It's not significant. Look, right? That's not a significant change. It's going to go from negative 0.07 to positive 0.03, and that's not a significant change, right? That also makes sense. I still can't access anything if I have a phone that's off. Now let's check what happens when my phone is on. It's silent. What happens when my phone is on? It's silent. First of all, is it significant? Yes, right? So when my phone is on silent compared to a calculator, right, the relationship between positive impulsivity and working memory is going to change, right? And in fact, it's going to go down by an additional 0.22 standard deviations. Right? So I started, when my calculator's on the desk, I'm at negative 0.07. That's almost flat. In fact, it's not significant, so it is flat, right? Then what happens once my phone is on the desk and it's on silent? Boom, right? Why? Because now my positive impulsivity is having a negative effect on my working memory because I am being impulsive about potentially checking what's on my phone. Let's look at that visually. We're gonna run a different code for moderation graphs for categorical, because we're splitting it by categorical levels instead of one standard deviation. Of our moderator is not high, one standard deviation low, it's groups, right? Calculator, phone off, phone silent. So we're going to use our usual ggplot that we use to graph stuff. X is positive impulsivity, Y is K, working memory, and group is whatever your moderator is. So it says group equals group. That's because in our data, it happens to be called group. Do you see that? That's very important. Make a note of that. Make a note of that. Make a note of that, right? Otherwise, this will be group phone or whatever it's called. Color is also going to be whatever that's called. And here's what that looks like. And here you can see what this is kind of cool because you can see the simple slope effect almost visually, right? So if that gray area encompasses a flat line, what does that mean? It's not going to be significant, right? So you see it already. You see the calculator line? We already knew that that red line was flat, right? For people in the calculator group, this was not significant. You can see it here too. This red encompasses it. Now, we're never gonna trust visualizing. So we can also run our simple slopes, right? Which is the same, you see this? It's the same function that we ran before. Sim slopes, model, predictor, moderator, and you get the same thing. So interesting. What do you notice? Cool result, right? We already saw this in the betas, right? And the Bs. What happens when I have a calculator on the desk or when I have an off phone on the desk? Not nothing, something happens. What happens? You should have when you're saying what happens, I should hear two variables in there.
There's no relationship between negative impulsivity.
Good. If I have a calculator on my desk or my phone is off on my desk, my positive impulsivity has no impact on my working memory. What happens when my phone is on the desk and it's silent? As positive impulsivity goes up, so the more impulsive somebody is, what happens to working memory? It goes down. So if you're positive impulsive, maybe put your phone away. Guess what? Spoiler alert, same thing happens with negative impulsivity. Yes.
This reason, you know, if the phone was face down or not.
I don't know. I would guess you don't know.
Remember there was a study, didn't one?
This is an actual study. I don't know.
We looked at something similar.
Oh, really?
There was one that came.
Oh, same study. It's the same data. I don't think it says. If there's the actual article, I think is somewhere online. Although I don't know how you put a calculator face down. That would be very different, right? If you could see and also our notifications turned on. Is your screen turned on? So many variables there. Totally. By the way, I don't have it in here. Look at the continuous demo here real quick. Remember how we standardized the model? You see that? You can do that in categorical too if you want betas instead. You standardize the model. So this is model PI, standardize model PI, and then run it. You'll get the exact same thing. You'll get betas instead of Bs. It won't work on mine, it'll work on yours because something's wrong with my R right now. It's up there. Oh, it's in files, not the module. It doesn't matter. It's always in files. Cool. All right. I'll stick around for a couple minutes. Oh, wait.
Might be having problems with Pequod. It looks like it's been taken down from the depository, where the
Oh.
code comes from.
Bummer.
The archive one worked.
Figure out a solution.
The archive one worked fine.
On the current archive, you go and the 2016 version one. Just download it and install it slightly differently than the install package.
That's a little bit of a pain, so if you need help, let us know.
Yep.
I registered for me, but it's still run on the desk.
So that might be, so that you might not actually need Pequod. Hold on. You might not need it. And the reason is because I used to have multiple ways of running simple slopes, one of which was Pequod. I'm not using the Pequod simple slopes function anymore, and so they probably don't even need it.
That's good, perfect.
This is a better simple function than the Pequod one. Reminder again, if your modality is going to change for Thursday, please let one of us, me, know. Otherwise, we will see you on Thursday for an entire day of moderation prep. Yes, Ray. By the end of the day, they're done. They're done. Took us 2.5 hours.
Oh, no.
The others.
Sometimes you can, I don't know.
How did you do that? I need to know. Like,
I don't
the
know.
ever.
I have no idea. It's scrolling right now. It's scrolling right now.
Yeah.
I have no idea. It normally doesn't.
If I can manage this,
I know. I don't know. No idea. Well, normally my heart. Yes, it's online, V. It's in files, moderation. The modules are replicating what's in the file.
I can't scroll. It's like I want to have a long result. I can do Please only have to. Yeah.
Yeah.